Alright folks, so in the last video we've added a little functionality to add some player to our game, and that's cool. At this point in the development, when you've finished adding your players to the game, you should sort of like have a way to tell that the game is ready to start, right? So that is where we are. So let's run our test, see where we were. And oh my god, so many errors. What happened? So, in the background, I've actually updated my version of the Google Test Framework, and as you can see, it only now supports C++17. And I think my Clang version by default will probably compile like C++11 or something like that. So we need to sort of tweak a bit the makefile. So you can see here that the test executable is compiled using the C++ flag. So let's naively add the minus std is equal to C, I think, plus 17, and try that. How's that gonna work? That isn't gonna work because you can see that when it compiles the O object here, from the C file, it's actually using Clang, because it is a C file, right? So Make is smart enough to pick the right compiler for the job. So what we need to do is to split that C flag stuff and create the CXX flags, which is the standard name for the C++ flags, environment variable or variable. And so we need to grab those, extract this out into its own variable. Let's call it includes. I believe that's how they're usually called. This variable, so the C flags is going to use this, and also the C++ flags. And obviously this is going to go with the C++, but when we're at it, let's set the standard for the C compiler as well to C11. So that's good. And here now, let's use this as the C++ flag, and I believe this should fix our problem. And it has, indeed. It has. Brilliant. Cool. So let's go back to our source code in the risk.c. Well, when I was rewatching the episode, I noticed something absolutely atrocious. Something some decent C developer would never do. It's I don't know if you can spot it, but in the game create function there is a bug. The bug is a memory leak. So here we allocate the player, and if we fail to allocate the player, that means there's no more memory. We just return null. The thing is, we've allocated that game structure on the heap, and now once you return from this function, there's no way to free it because we don't have the pointer, and there's no way to access it. So what we need to do, we could do something like just free game, and that's it. But we are good citizens, and we're just gonna create a function just to deallocate the entire game structure. So let's create a function void that's gonna be game destroy, right? And then we're gonna pass it the game as well. Game t, pointer to a game. If game is null, then we can return. Yeah, that's good enough. And then if game dot players, so if there is still a players array allocated, then we are going to free this players memory space, and then we can actually free the game itself. Right, cool. That means now we in the game create, we can actually game destroy, Yeah, game destroy, boom. And it's complaining because like there's no forward declaration, so we need to add this to our risk.h, because that's something we definitely want to expose. There you go. Risk.h, game, yeah, need to add that as well. And if we run the test now, oh, that doesn't work. What is going on here? Game destroy. Game destroy. Oh yeah, it takes the game as an argument. Just me being a bit silly. All right, let's compile. Test runs. Perfect. Now let's actually call this as well in our test. Because just be nice, and that's cool. All right, great. So we fixed that. That's pretty nice. So now we need to create a function that just say, hey, let's create the game let's make the game ready. So actually, let's use the test that we already have. So when we create the game, we can expect that. So we're going to have a flag for this, which is going to be called ready to start. And we expect this to be false. All right. And we're going to expect this to be false pretty much when we add all of the players except the last one. The last one, we wanted to change it to true, because once you've added the maximum amount of player, well, then the game is ready to start, right? So let's add this to let's run the test and then say, oh, okay, there's no such member ready to start in game T. So let's add it to our header file. Let's add it here. Let's make this a bool and ready to start. And there you go, which is good. And okay, we have a test failure here. Let me restart the LSP, and you can see that it is not true because we haven't implemented this at all. So let's go to our risk.c for good measure as well. Here, let's initialize the flag ready to start when we create a game. Ready to start to be false. Yeah, there you go. Now, when we add a player, let's say we've added the last player we can add. So that means if the player count is equal or greater to max player, then we can say, okay, great, the game is ready to start. We can set this to true. Let's run this. Okay, wonderful. So that works. And are there any other things that we need to do? Yeah, no, that's all right for this. And okay, let's go back to our test. And now we're going to create a test we're going to create a function that just say, let's say we only had 3 players. We need to be able to tell the game that it is ready that we've closed we are closed for player registration, basically. So let's call this function game closed for registration. No, that's not a great name. Yeah, game closed. Game registration closed. Game player registration closed. Yeah, I'm not quite satisfied with this name, but let's roll with it. Let's roll with it. And so first thing, we're going to need a game. So let's create the game. Excellent. Oh, so there's not. That is game create. That's why. And then let's game add a player. Okay, let's make this a black player. Okay. At this point, we should expect that equal that game dot ready to start should be false. And then we also, let's call this function, and we're going to expect equal. So the way this function, actually, let's backtrack a bit. Let's add another player. Right, no. Actually, let's just call that function. And then, so this function is going to return a status code, basically. So we need a status code, which is going to be okay. Let me because when you can only play this game with more than one player, between 2 to 6 players. Like, it doesn't make sense to play alone. So at this point, the game only has one player, so we should expect that it returns something that says A, or that's not right. You can't. There's not enough players for the game to close its registration. So we're going to have an error code for that. And so we're going to call this function, and we're going to have an error code that's called game not enough players. Right? Something along those lines. And then we're going to add another player. Let's go. Let's make a red player. And then we're going to call this method again, and then that should return game success. And let me spell that right. Cool. Let's run the test. Obviously, it's going to fail to compile because there's a bunch of things that don't exist. So let's take the first error. So game registration closed does not exist. So let's go and add this to our header file. Excellent. And so that is a function that is going to return. So we're going to make an enum type for that. So that's going to be type def enum, and that's going to be game results. Yeah, let's actually call that game results. And so we're going to have a game success to be the first one, and then we're going to have game not enough players. Cool. That's going to be game results as well. So this function is going to return a game results. Oh, what is going on? Okay, and we need to pass it the game in. Oh, my LSP is going a bit rogue. Which is going to be a game T. Something is happening. And game. Oh, okay. Hang on. I need to restart this LSP, which is going completely nuts. Okay, cool. Now let's run our tests again. And so no matching function called game. Oh, okay, cool. So that is because in the test I am not passing the game in the function call. I'm going to pass it here and there as well. Run the tests. Excellent. So now we need to actually implement this. Right, game. So that is going to be return a game result. Okay, and pass a pointer to a game. And that's it. Okay, so game results. So if game dot player count is greater than 1, then that means, yeah, game ready to start is equal to true, and then we can return actually game success done. Otherwise we just return game not enough players. Let's run our tests. Okay, cool, great. And okay. Let's go back to our tests. Do we need to do anything? I think it'd be nice to make the game being an opaque type, meaning that you don't really have access to its members directly. But is it something? No, I think we're good. I think we're good now. We're good. So I will see you in the next episode.